All right, we're gonna go ahead and get started here. So let me turn on my timer. We got 5 minutes to do these two problems. I recommend, good morning, I recommend doing a graphing calculator for these. Okay, so make sure you guys open up Desmos graphing calculator. Here, I will get mine up so that you guys can see it as well. And let's get started. So good morning, everybody. Let's get started on this warm up. Yeah, good morning. Good morning. I'm glad you guys are here. All right, so let's go over these two problems. We're going to be adding, so today is our last day talking about graphing quadratics, and we're going to be adding just one more thing to it. Well, actually, two more things. So we got two more things that we're adding today, and then this will be our last thing that we do with graphing quadratics. Okay, cool. So, in fact, I'm just looking at the schedule right now. This is our last lesson for the trimester. Whoop whoop whoop. Right? So this is our last new stuff. So the next 3 classes after this, we're going to be reviewing what we've learned this trimester, and then practicing getting ready for the final. Right? So that's what we're going to be doing. So you guys have made it. This is our last new lesson for the year. That's pretty exciting, right? I mean, it's been a long time coming, huh? So let's take a look at this. So I'm going to graph this here. So I got negative 2x squared minus, oops, pop-up window, minus 4x and then plus 3. Here, I can make this a little bit bigger, can't I? There we go. All right, so we need to find some stuff here. So we want to find the axis of symmetry. So if I look at my graph, right, the axis of symmetry is going to be what breaks it down the middle. So I can do that by looking at my vertex, right? So the line going up and down, so I can kind of think about it, right? If I had a pencil here, it would be like this, right? So there's my line going up and down, cutting it in half on either side. Okay, so what we're going to do then is say, okay, so the x value here is -1. So my axis of symmetry is x equals -1. And how are you guys doing with that? Are you guys doing okay with axis of symmetry? Right, the axis of symmetry is the same as the x value of the vertex. So our vertex, right, is going to be, what do I have there? -1 and 5. Okay, and again, I really do believe that using the graphing calculator is the easiest way to do this. So if you guys have any questions about graphing calculator, what we're looking for, how I did it, just let me know and I'll help you guys out, right? Because if you guys don't say anything, then I'm just going to assume you guys get this. Okay, now the new things we learned about, right? Domain, and hopefully you guys remember that with domain, what's the domain for a quadratic always going to be? Type it in chat. What's the domain always going to be for a quadratic? You guys type that into chat. What's the domain always going to be for that? Yeah, there we go. You guys are awesome, right? It's always going to be all real numbers, right? And you guys aren't going to get into functions that have domain restrictions until not next year, until Algebra 2. So you guys are just going to be taking geometry next year. And we're not going to quite get to anything where there's domain restrictions, so we're just kind of introducing it. Okay? So all real numbers. You guys are wonderful. Okay, so then the range, right? The range is the one that we need to focus on. So that's the output. So when I look at this graph, the thing that I notice is it goes down forever. Do you guys see how it goes down, 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 down? But, so right, all those negative numbers work, but it goes to a peak here, right? And that peak is our vertex. And we're going to spend a little bit today naming this. But it doesn't look like this graph goes any higher than the vertex, which is 5. So I'm going to say the range is y, and y represents the output. So the output is less than or equal to 5, right? So remember that means, and you can always think of it, the alligator eats the bigger numbers, right? Nice, nice. That feels good. Right? it's good to have this stuff locked down. That means you're going to do well on the assignment and hopefully well on the final as well. That's really good. Okay, so we're going to do, if any of you guys have any questions here, let me know. We're going to go ahead and do the second one, and then we're going to talk about the two new things that we're going to work on today. Okay? And then we'll put it all together. All right, so I'm going to move this over, and then we're going to graph this one. So I got to make this a little bit smaller. All right, there we go. So I'm going to graph, so my next one I'm going to graph is 3x squared, and then plus 6x, and then minus 2. Okay, I'm going to have to zoom out a little bit. Go like this. Okay, so the first thing I'm going to do, so the axis of symmetry. Okay, so that's where it's being split in half. And the pro tip here, you can always just, I think, finding the, oh my gosh, it's 1, -1. I just made -5. So it looks here, right, that the vertex, right, I find the vertex first. So that's -1, -5. So the axis of symmetry is going to be x equals -1. I didn't intend for them to be the same, but there we are, right? Guess my brain just automatically did that. All right, and then, so we have the axis of symmetry, right? That's what's going, it's the same x value as our vertex. And then let's do domain. So my domain, right, is going to be all real numbers. You guys, right, hopefully on the final, this is going to be free points for you, right? All real numbers, free points, because the domain is always going to be the same for quadratics. Okay, and then the range, so we got to be careful here on the range. It looks like the function goes up, right? So it goes up forever, but it has a low point. And that low point, right, we can click on this, is going to be the vertex. Oops, why am I having difficulties clicking on it? There we go. So the range, it looks like it's going to be the output is greater than -5. So it's everything -5 and bigger, right? Everything -5 and bigger. It can be -5, right? That's the lowest point, and we're going to give a name for that today. And then it goes up from there. Okay? So does anybody have questions or concerns or just like general calculator issues? And remember, on the final, you guys can use this graphing calculator, right? You can also use this graphing calculator on your assignments. Well, if you guys don't have any questions, this is really good because we're going to finish this up today. We got 2 things that we're going to add. So I'm going to hide this calculator over here. So that way I don't have to get it back in. So what we're talking about today is we're talking about 8.3 day 3. And we're going to talk about a value and maximum and minimum. Am I going to run out? So the a value and maximum and minimum. So those are the things we're going to talk about today. So the a value, maximum, and minimum. I probably could have put commas, but you know, and works. Okay, so I have a value, maximum, and minimum. It's kind of like max and then imum, and then min and imum. Okay. All right, so let's go ahead and take a look at what these are, okay? So hopefully you guys noticed, right? So we have standard form. We have ax squared plus bx plus c, right? So this is, we have standard. Okay. And what we want to take a look at today is, what does the a tell us? Okay, that's what we want to look at today. So that's going to be, what does the a tell us? And then we're going to use these fancy words, maximum and minimum, to describe those things. Okay. So the first thing that we're going to do is we're going to have two situations. Okay. So we're going to have when a is positive, and we're going to have when a is negative. And sometimes I put quotes around it so that way we know we're not just doing a sentence. So we're going to make a little table here. So what does the a tell us? So when a is positive, and then when a is negative. And we're just going to compare these and see what we can come up with. And I'm just giving some time for people to write it down. I don't want to be going too fast. All right. So for each of these, we're going to do a graphing sample. Okay. So we're just going to be looking at the a term. So let's pick 3x squared, right? Where a equals 3. So that's going to be 1. Okay, so 3x squared where a equals 3. And then my other example is going to be negative 2x squared, right? Where a equals negative 2. Okay, so we're going to take a look at both these examples. Okay, we're going to see, what does a do to the graph? So let's take a look at our first one and see what happens. So we're going to do the positive one first. So I'm going to clear this out. So I'm going to try 3x squared. Oop, I am not on there. There we go. So I have 3x squared. So I'm going to just quickly sketch a graph of this into my notes. So 3x squared looks something like this. And remember, it's just a sketch. So it's not meant to be accurate, but it's just supposed to catch the spirit of the graph, right? The big picture. Okay, so 3x squared there. All right, so the next thing we're going to do is we're going to compare this to negative 2x. So to compare them, I'm just going to click on the 2. I'm not going to erase it. So I have 2 at the same time. And then I'm going to go negative 2x to squared. Okay, and what I get here, and I'm going to make this nice and big, is I get this purple graph. Okay, so if I move this graph over, I'm going to graph that here. So I'm going to graph, so if I had a coordinate system, it looks like this. Okay, so I'm going to try to bring this up. So we have these two graphs. One is going up, one is going down. So with that said, what do you guys think the a tells us? Can someone write it out in chat? What do you guys think? What should we write down? What's the a doing? What's the a telling us? Yeah, so if it's positive or negative, what does it do? So when it's positive, what happens? And when it's negative, what happens? I think that's a really good point. So we're definitely looking at it positive, negative. And when it's positive, what does the graph look like versus negative? Yes, yes. So guys, share it in chat. Go ahead. Go ahead. Yeah, yeah, yeah. Ooh, and be more descriptive than the opposite, because right, like that's assuming there's a standard, right? There we go. Yeah, 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 yeah. Yeah, yeah, yeah. Okay. All right. So you guys are seeing the pattern, right? So I'm just going to write that down in our notes. So when A is positive, right? This is how I like to think of it. I like to add a little face on. When A is positive, we get a smiley face. Here, I'm going to get rid of my graphing calculator really quickly. Sorry about that. Okay, so when A is positive, we get a smiley face. Okay, we get a happy face. When A is negative, oops, probably like that, right? When A is negative, we get a sad face. Okay, so I know that's kind of like, silly language, but when A is positive, it opens up. And then when A is negative, it opens down. Okay, so that's the big takeaway we need to take away from this. So we can know this before we graph this, right? We can know this without graphing, and that's going to save us so much time if we can just look at an equation and say, hey, I know this is opening up or down. And I'll show you why in just a little bit, okay? Okay, so that's kind of the big thing for today. If A is positive, then it's smiling, it's opening up. If A is negative, then we're kind of a sad face, and it's opening down. Okay, it's a weird sad face to make, but nonetheless. Okay. All right, and I'm just giving people a little bit of time to make sure they have that all down. Now, the last thing we want to add, so we're going to add one more thing to this table, and that is, notice when it's up, right? Think about the range. That means that right here, our vertex is a minimum. And so our vertex is a minimum. And a minimum means the lowest point. Okay, so our vertex is a minimum. That means the lowest point. Okay, so minimum means lowest point. So like if you were going to get a new job, the employer might say, well, you're going to make at minimum, right, $18 an hour. So if you're making so that's the minimum amount you'll make at their business. It means you could make more, right? But that's the bare minimum. It's the lowest. Okay, so our vertex is a minimum, and that's the lowest point. And then here, our vertex is a maximum. So that means it's the highest point. Okay, so if you went to a business and said, well, you're going to be making $25 an hour max, that means if you work for that business, you're never going to be making more than that. Okay, so our vertex there is our maximum point. Okay, so we have, so A tells us a lot, right? So if it's happy and opening up, the vertex is a minimum. It's the lowest point. If our A is sad and opening down, then we're going to have a maximum. We're going to have a highest point. Okay. And knowing these things is going to speed up a lot of things in the future. And so that's why we learn them now. You guys are like, why are we learning this? Well, in the future, this is going to speed things up quite a bit. So we spend time learning this. Okay. So what we're going to do now is we're going to add this to our vocabulary. We're going to add minimum and maximum to our vocabulary. So we're going to be doing everything we did before, but now we're going to be finding so much information. We're going to be finding the axis of symmetry. We're going to be finding the vertex, the y-intercept. We're going to be finding if it does it have a max or does it have a min, and where is it? Okay. Now, the cool thing about quadratics is that the vertex is going to be your max or min. So really, you just need to say, is your vertex a max or a min? So you're going to find your vertex and then say, is it a maximum or minimum? Okay. How are we doing so far, guys? You guys ready? Do you think we could try a couple of problems out and see how we do? Here, let's practice. Yeah, maybe, right? Like, you never know until you practice. So that's I would say that's a good place to be for practicing. Maybe is a good place. So let's practice just with this A positive, A negative bit, and then we'll add everything in together. So we'll do baby steps, okay? So we're not going to rush into it all at once. Okay. So let's just do a couple of examples of that. So let's do. Will the following open up or down? Will they have a maximum or minimum? Okay, so will the following open up or down, and will it have a maximum or minimum? And we're just going to practice that for a little bit. And my challenge to you guys is try to do it without a graphing calculator, because a graphing calculator is going to take more time because you're going to have to open up the graphing calculator, type it in. Right now, if you feel like, crap, I'm going to use a graphing calculator, okay, like I'm not going to stop you, but try to do this without a graphing calculator. So let's take a look here. Okay, so there's our first one. And then here's our second one. Okay, so you're just going to look at these and you're going to say, and I'm just going to give you a little bit of time to do this. Okay, so let's do a minute 30, because you shouldn't, so it should be quick because we don't have to use our graphing calculator. You're just looking, is it opening up or down? Does it have a max or a min? Use your notes. All right, so let's take a look at this. So again, this can go really quick without a graphing calculator. So all we're looking at is we're looking at the a term. So I see here a is negative. Right? It doesn't even matter that it's a fraction, right? So a is negative. So that means we're going to open down. Now, I'm not going to lie, guys. I never remember if it's a max or a min. So you guys want to know the secret and how I do it? I just go like this. Okay, so I know it's opening down. Right? I just draw a little picture and then I'm like, oh, that's the highest point. So then I say it's going to have a maximum. Okay. So again, if you guys are like me, where I don't memorize things well at all. So if you can just say, hey, it's opening down, you can draw a little picture and then you can be like, oh man, that's the highest point. That's a maximum, right? It can't get higher than that. Okay. So I would really suggest people sketch a little graph. It just makes things a lot easier. And then again, if you guys have questions, go ahead and ask. So for this one, I take a look. The a is 6. So the a is positive. So if it's positive, I think, oh man, that when I'm positive, I'm happy, right? So then I think, okay, it's going to open up. And then I'm going to quickly just sketch a little graph like this. So if it's opening up, that means that I'm going to be at, this is my lowest point. So having a lowest point means I have a minimum. Okay. How are people doing? Does anybody have questions or comments or concerns? Did you guys see how I did that? And I really do think that just sketching the graph, like for these questions, you don't have to graph it, right? Now, for finding everything else, then sure, go ahead and graph it, right? But you could just quickly sketch it and just be like, oh, yeah, this has a max or a min. You guys doing okay? Does anybody have any questions? Okay. So what we're going to do is we're going to tie this together with everything. Okay, so we're going to do 1 or 2 equations, and we're going to have to find absolutely everything. Okay, so let's say our function is, let's go, here, I'm going to pick something that doesn't have horrific numbers because that can get frustrating. So 8.3, sorry, just 1 second. I have a problem picked out here that we can do. Okay, so let's go with this one. So we're going to have g of x, right? That's just a function name. We're going to have 8x squared minus 8x plus 6. And these are all the things I want you to find. I want you to find the y-intercept. I want you to find the vertex. I want you to find the axis of symmetry. I want you to find, is it opening up or down? No, let's just do, have a max or min. So that's the abbreviation. Does it have a max or min? Okay, so I'll give you guys a little bit to work on this. I think 2 minutes is going to be a good amount of time to do that, to open up your graphing calculators and do this. And I will open up mine as just an example of to do that. I gotta make it a little bit smaller. There we go. All right. And then go ahead and answer those questions, guys, and we'll see where we need a little bit more help, okay? Ooh, does it have a max or min, and what is the point? Okay, let's go over this, guys. And again, if you have questions, let me know. So let's take a look. So the y-intercept. So I know people in the past were having troubles with the y-intercept. So I thought we would go ahead and start out with that one. So again, the y-intercept, right? So if we look at 0, right? 0, 0. The y-intercept is the one that goes up and down, right? Like this. So if we click on our graph, right, there should be a gray little dot where it crosses the y-axis, right? So, right, when you graph it on Desmos, it finds the y-intercept for you. You just have to know which one of these gray dots is the y-intercept. So if I go here and click, I don't know if you guys can see that. I need to maybe make mine a little bit bigger. Here, let's turn this off. Okay, so if we take a look here, why can't I move you? There we go. Mine says 0, 6. So the y-intercept is at 0, 6, like that. Okay. Anybody have questions about that? So again, it's just about graphing this on Desmos and then knowing where it is, okay? Another way you can think about it is notice how our x, right? Our x is 0. You can also plug in 0 into your equation. So notice 8 times 0 squared is 0. Negative 8 times 0 is 0. And I'm just left over with 6, right? So that's another cool way of finding the intercept, is just plugging in 0 for x, okay? And when you get to higher levels math, right, that's a really cool trick to just quickly find your y-intercept. You just plug in 0 for x. All right, the vertex. So that's another place we're going to have to click, and that's going to be down here. So on my calculator, the vertex is 0.5 and 4, right? 0.5 is the same as 1/2. So if you wrote 1/2, that's perfect. That's great. So the axis is symmetry, right? So I'm going to go ahead and write it as both ways because both ways are perfectly fine, right? So your axis of symmetry is x equals. And yes, you have to have x equals. If you just wrote a half, that's not correct because the axis of symmetry is a line. So it has to be x equals. Okay, it has to be that x equals. Does it have a maximum or a minimum? So if I look at this graph, it looks like it goes up forever, but it can't go lower than this. So we're going to say it has a minimum, and the point of that minimum is our vertex, right? So 0.54, right? So that means 4 is the lowest value. Right, a little bonus stuff there. So that means 4 is your lowest value, right? That whatever this function is representing, 4 is the lowest it can go. Okay. So are you guys okay with this? We're going to do one more and we're going to call it good for the day. So we'll just do one more unless people are struggling or have any questions, but no one's asking questions so far. So let's do one more and see where we are, okay? Okay, so our last one for the day is going to be, I got another one here. So let's do h of x equals, let's do negative 1/4 x squared plus 3x plus 1. And you're going to find the y-intercept. You're going to find the vertex. You're going to find the axis of symmetry. And you're going to say, does it have a max or a minimum? All right. So I'll give you guys the same amount of time to do that, and let me know if you have questions. All right, let's go over this, guys. So the first thing I'm going to do is I'm going to make my graphing calculator bigger again. So there we go. And let's move this over so I have room for it. Okay, so I'm going to type in my equation. So I have -1/4 and then x squared. Oops, not to the 25th though. And then plus 3x and then plus 1. Oop, gonna have to move this over and go like this. Okay, so I want to find the y-intercept first, so I'm going to click on this, and then I'm going to go to my y-intercept. So it looks like my y-intercept is going to be at 0, 1. Right, this is my x, that's the y. And then I'm going to find my vertex, so that's this point up here. So it looks like it's 6, 10. Which means my axis of symmetry is 6. And I am looking at this, I'm going to have a maximum right at y equals 10. All right, did anybody have questions or comments or anything like that? All right, guys. So today's lesson didn't have a lot in it. It was just making sure that we were pacing and going at a nice pace. So I do want to give you guys a heads up of what's going to be happening now. So today is our last new material for the year. So what we're going to be doing between now and our final is we're going to be reviewing everything we did. So tomorrow, we're going to have an assignment for this, right? So our last assignment for 8.3. And then next time we meet on next Tuesday. So we have to remember we don't have school on Monday. You guys are going to have a 3-day weekend. So things get a little bit weirder now. So that means next Tuesday, you guys are going to learn, we're going to review 9.3. And then Thursday, we're going to have a little practice on that. And then Friday, we're going to review 9.5, and then the week after that, on Monday, we're going to do a practice 9.5, and then that means then the week after, the Tuesday after that, we'll do 8.3, and then we'll do that. Yeah, this Monday coming. So Monday the 31st, there is no school on Monday the 31st. So you guys have a 3-day weekend. And then seniors are going to be taking their finals today, tomorrow, and Monday and Tuesday. Okay, so I just want people to be aware of that because we have no school on Monday, right? Our schedule's going to be off a little bit. So like it has been Monday and Thursday have been our lessons, and Tuesdays and Fridays have been our practice days. So tomorrow will be a practice day, but starting next week, it's going to switch. So it's going to mean that Tuesdays and Fridays are our lessons, and then Monday and Thursday are going to be our practice days, okay? And we're going to review 9.3, 9.5, and 8.3, and then you guys are going to take your final, I think it's the last Monday of school. So if I remember right, that's going to be June 14th. So what we'll do is we'll have time in class June 14th to take the final, and you'll have time in class on June well, they're going to change. Oh my gosh, they're changing the schedule. So I'm going to give you guys time in class to work on it on Monday, but it won't be due until Wednesday. So you guys will have 3 days to work on it, okay? But we'll talk more about that. They're changing the schedule the last 2 days, and I don't want to confuse anybody, so we're not going to talk about that. So again, you have a 3-day weekend. I will see you this weekend. I will see you guys tomorrow to do a work. At this point, class is till 11:25.